Hello, I welcome you back to another tutorial. My name is Protocol. In this tutorial, we shall be looking at finding the rule for exponential mapping and then exponential reciprocal mapping. So what is an exponential mapping? If you talk about an exponential mapping, we are talking about any kind of mapping in which the elements of the codomain differ from each other by a common ratio, which is usually denoted by the letter R. Now, if the elements of the codomain are fractions with a constant numerator, while the denominators differ by a common ratio, then the mapping is said to be an exponential reciprocal mapping. Now, what you have to know is that all exponential mapping follow the rule y is equal to a r exponent x minus b, where a and b are equal to y1 and s1 respectively, which means that a is equal to y1 and b is equal to s1, and r is the common ratio in the codomain. Let me use this example to explain what an exponential mapping is. So looking at this example, x map to y, and the domain, that is the x values, start from 0, 1, 2, 3, and 4. So 0 map to 1, 1 map to 5, 2, 5, 2 map to 25, 3 map to 125, and then 4 map to 625. Now, looking at this mapping, if you want to know if the mapping is an exponential mapping, then it means that the codomain should have a common ratio, which is normally represented with the letter R. How do we find that common ratio? The common ratio is the constant factor between consecutive terms. How do we get that factor? We can obtain the common ratio by dividing a term by its previous term. Okay, so looking at the codomain, the first term is 1, the second term is 5, the third term is 25, the fourth term is 125, and then the fifth term is 625. So we are saying that to get the common ratio R, we have to divide this term by each preceding term. That is the fifth term divided by the fourth term, and also the fourth term divided by the third term, and then the third term divided by the second term, and lastly the second term divided by the first term. So if we do that and the result we get is the same, then that result is what we are saying is the common ratio. So let's check it and see the result we are going to get. Now, 625 divided by 125. What is the answer? Clearly, we are going to get 5. Also, 125 divided by 25. What is the result? The result is also 5. Now, 25 divided by 5. What do we get? We shall surely get 5. And 5 divided by 1 is also 5. Therefore, this 5 is what we are calling as the common ratio. Or, the common ratio is a fixed number that is used to multiply the previous term to get the next term. So, here, this is the first term. So, to get the next term, we have to multiply the first term with a number to get what? 5. We use the same number to multiply 5 to get the next term, which is what? 25. And also, to get the next term, we have to multiply this number with that same number to get what? 125. And lastly, we use the same number to multiply 125 to get this number. So, that number is always fixed. And if you're able to get a number like that, then that number is what we are saying is the common ratio. Now, from here, which number do we use to multiply 1 to get 5? Clearly, the answer is what? 5. So, 5 multiply 1. The result is what? 5. So we are here. To get the next term, we have to use that same 5 to multiply this term. So we have this 5 multiplying the second term, which is 5. And when we do that, we shall get what? 25. Now, the same 5 will be used to multiply this term to see if you are going to get this term. And when we do that, we'll be having 5 times what? 25. And this will surely give us 125. And lastly, that same number will be used to multiply this term to see if we get this term. So, 5 times 125, obviously, we shall get 625. So if you look at it carefully, you realize that the 5 here is constant. Therefore, this is the common ratio. So you can do that also to get the common ratio. Now, we are able to establish that the mapping is an exponential mapping because the codomain is having a common ratio. So as soon as we have established that the mapping is an exponential mapping, then we know that all exponential mapping follow this rule. Y is equal to A R exponent x minus b, and R here represents the common ratio in the codomain. And when you calculated, our common ratio is equal to 5. Now, A is y1. That is the first element in the codomain. So my A will be equal to 1. What about the B? B is S1. That is the first element in the domain. So clearly, my B will be equal to 0. Therefore, our rule for the mapping will be Y is equal to, what is my A? My A is 1. What is my R? My R is 5. Exponent x minus b. What is b? B is 0. So I now have y is equal to 1 multiplying 5 exponent. So x minus 0, I will get x. And I will be having y is equal to 1 multiply 5 exponent x. I will have out 5 exponent x. Now, clearly, 1 times any number is the same as that number. So I have y is equal to 5 exponent x. And this is the rule for the mapping above. Let's look at our second example. So we have x mapped to y and -1 mapped to 4 divided by 9. 0 mapped to 8 divided by 27. 1 mapped to 16 divided by 81. 2 mapped to 32 divided by 243. And lastly, 3 mapped to 64 divided by 7 to 9. Now, we want to find the rule for this mapping. So first of all, let's determine if this mapping is an exponential mapping. How do we do that? We find the common ratio in the codomain. So to do that, we'll divide this term by the previous term, and also this term by the previous term, this term by the previous term, this term by the previous term. Now, if you do that, you are going to have 64 divided by 729 all over 32 divided by what? 240. So we have 64 divided by 729 and all divided by 32 divided by 243. This is equal to 64 divided by 729 divided by 32 divided by what? 243. And when you do that, you are going to get to third. Okay. Let's do the next one to see if you are going to get to third. So we have 32 divided by 243, and that is also dividing 16 over what? 81. So I have 32 divided by 243 divided by 16 over 81. And when I do that, I will surely get to third. Okay. Let's go to the next one. That will be this number divided by this number. So you have 16 divided by 81, and this is divided by 8 over 27. And when I do that, I will have 2/3 as the answer. Let's go to the next one. That will be 8 divided by 27, and that will be dividing 4 by what? 9. So now I have 8 divided by 27 divided by 4 over 9. And clearly, I will have 2/3. So as you can see, we have a common ratio of 2/3. Now, let's proceed with the work. So my R is equal to 2/3. So once we are able to get the common ratio in the codomain, then it means that the mapping is an exponential mapping, which follows the rule y is equal to a r exponent x minus what? b. And we have already calculated for r. Our a is the first element in the codomain, that is y1. And our b is the first element in the domain, that is s1. Now, let's proceed. So we now have y to be equal to a. A is 4 divided by 9. That's the first element in the codomain, as you can see here. Multiplying r. What's my r? My r is what? 2/3. Exponent x minus b. B is the first element in the domain. In this case, it's -1. So x minus -1. That's very good. Let's go ahead and simplify. So I now have y is equal to 4 divided by 9, and this multiplying to 2/3 exponent to x minus -1. I will have x plus 1. That's good. Now, let's simplify to have y is equal to 4 divided by 9, and this is multiplying to 2/3 exponent x times 2/3 exponent 1. So I'm using some lots of indices here. Okay, let's proceed. This can also be written as y is equal to 4 divided by 9, and this will multiply 2 divided by 3 exponent 1 times 2 divided by 3 exponent x. You know, multiplication is commutative, so the position of the numbers does not have any effect on the answer. So as you can see, this one is multiplying this. So if I change position of them, the answer will still be the same because they are multiplying, and multiplication is commutative. So we now have y to be equal to, now 4 divided by 9 can be written as 2 square divided by 3 square, and then this will multiply to third exponent 1 times to third exponent x. So we now have y to be equal to, this can also be written as 2 divided by 3 all square times 2 divided by 3 exponent 1 times 2 divided by 3 exponent x. Let's proceed. Now, we have a law in indices that says that if you have a base, let's say a exponent m times the same base exponent another number, let's say n, then once the base are the same, then write the base and then add the exponent. So we now have a exponent n plus n. We are going to apply that law here. So let's go ahead and do that. So as you can see, the base are the same, that is 2/3. Therefore, we shall add the exponent. So let's go ahead and do that. So we now have y will be equal to 2/3 exponent 2 plus 1 plus x. Good. So what do we have? We now have y to be equal to 2/3 exponent 3 plus x, which is the same as y is equal to 2/3 exponent x plus 3. Therefore, the rule of this map is y is equal to 2/3 exponent x plus 3. And this is the rule for the example number 2. Let's look at our last example in this tutorial. So the last example, we have x mapped to y, and then 0 mapped to 1. Also 1 mapped to 1/2. 2 mapped to 1/4. 3 mapped to 1/8, and then 4 mapped to 1/60. Now, As I said earlier, if you have a mapping and the codomain of that mapping is a fraction and the numerator of that fraction is constant and the denominator differ by a common ratio, then that mapping is said to be exponential reciprocal mapping. So let's check and see if this mapping is an exponential reciprocal mapping. So let's go straight to the codomain. You know every number is over 1, so this one here can be written as what? 1 over 1. Good. So let's look at the numerator of the codomain. So we have 1, 1, 1, 1, 1. So as you can see, the numerator is constant, and in this case, it's 1. Now, let's check the common ratio in the denominator of the codomain and see. So let's do that. So to do that, we have 16 divided by 8. What do we get? We get 2. 8 divided by 4, you're going to get 2. 4 divided by 2, the answer is obviously 2. And lastly, 2 divided by 1, we shall get what? 2. Now, let's proceed. Now that we have established that this mapping is an exponential reciprocal mapping, then it will follow the rule y is equal to k over a r exponent x minus b, where we say this k here is the constant numerator in the codomain. So in this case, our k is 1. So I have k to be equal to 1. Good. And a is the first element in the codomain. So a will be equal to 1. B is the first element in the domain. So our b will be equal to 0. And r is the common ratio in the denominator of the codomain, this over 1. And when we calculated that, we got r to be equal to 2. So our r is equal to what? 2. So let's go ahead and substitute these values into this equation to get the rule for the mapping. So y will be equal to k. What is k? K is 1. So we have k, which is 1, over a. What is a? A is also 1. So I have 1 multiplying r, and my r is what? 2. So I now have 2 exponent x minus b. And what is my b? My b is 0, as you can see. So minus 0. So y will now be equal to 1 divided by 1 multiply what? 2. So x minus 0, I will surely get x. My y will now be equal to 1 divided by, so we have 1 multiply 2 exponent x. So I have 2 exponent x. and 1 times any number, you get that same number. So now I have y to be equal to 1 over 2 exponent x. Hence, the rule for this mapping is y is equal to 1 over 2 exponent x. Before we end this tutorial, I will give you some 2 questions to try on your own. Question number 1. We have x mapped to y, and we have 1 mapped to 2. We also have 2 mapped to 4, 3 mapped to 8, and then 4 mapped to 16. Let's take the second question. So number 2. We have x mapped to y, and then 1 mapped to 1/2, 3 mapped to 1 over 32, 5 mapped to 1 over 5/1/2, and finally 7 mapped to 1 over 8/1/9/2. Please take your time and find the rule for these 2 mapping, especially the number 2. I know you can do it, so take your time and do it. I thank you so much once again for watching this tutorial. Don't forget to subscribe to the channel and share the videos as well. We shall meet in another tutorial to discuss more. Bye bye.